Okay, a final classic question dealing with a so-called system of equations deals with the infinite geometric series formula, and that's so-called S sub infinity. And a bit of a background as to why the infinite sum of a number, or a series, I should say, is just dependent upon the first term and 1 minus r. So this is a little bit restriction. That's putting the r values between 1 and -1. So given I'm an infinite geometric series with the infinite sum being 36/5 and the second term being -8, let's find the first term and r. So this formula classically just consists of two components, first term and r. And so that is one of the formulae that we need because we know 36/5 was given as S sub infinity, the infinite sum. That's going to be the left-hand side equal to, as it turns out, an expression with these two unknowns. And then similarly, if u sub 2 is given as -8, well, that's still based upon a formula we saw earlier. The second term is equal to the first term times r. That's how such a sequence builds. And so since the second term is given as -8, we have the -8 equals also an expression in terms of the first term and r. So we basically have two equations, two unknowns, hence a system. And so all I've done there is say, okay, with these two equations and the same two unknowns, if we just sort of multiply this across, that's how the 1 minus r shows up here being multiplied against the 36/5. So that frees up u sub 1. And I can also just divide the r under, and that frees up u sub 1. And then once again, if this equals u sub 1 and if this term equals u sub 1, then these two equal each other. Hence this comparison or equating of the two terms over here. We can multiply both sides by 5r, and then doing so clears out these denominators and leaves us with something like what you see here. This is starting to feel a little bit like a quadratic, which it is. You could actually expand, and all I've done is move some terms around. We're going to have sort of negative 36r squared here. It's positive because I've moved it to the other side. We'll have positive 36r here. It's negative now because I've moved it to the other side. And I've brought the -40 over to join them. Actually, they both went over to the right to join the -40. So this is a quadratic, which you could solve using the quadratic formula. You could also reduce it down by dividing straight through by 4, factor, and these two factors, when you set each of these factors equal to 0, give you an r value of -2/3 and an r value of 5/3. This one's in red, can't have it. Why not? Because of this restriction here. For this type of infinite geometric series, the r value has to be between 1 and -1. That's what that's communicating to you. Hence, this root is thrown away. And so if the first term is only -2/3, you could plug it into either one of these to solve for the, if the r value is -2/3, you could plug it into either one of these to actually get the first term. Arguably, the second one here is the easiest, so let r be the -2/3 that it needs to be, and a little bit of arithmetic there gives you that the first term would be 12. That's it. Hope that was clear. See you next time.